Okay, so at this point, as we've been learning about u-substitution, I've showed you hopefully enough problems with the methods for you to see some patterns and at least get to the point where you can practice it yourself. Like here's a problem that we did in another video, for example. So I've done lots of problems. But I think to really learn this, we also need to see or get a feel for what problems we can use u-substitution on and what problems we can't. Okay? And I think it might be helpful to think of u-substitution as the reverse of the chain rule. So here's a completed problem. It says the indefinite integral of 3x squared times cosine x to the third power dx is sine of x to the third power plus c. And I just want you to notice about that, if for that x to the third right there, when you take the derivative of this to verify that it's the answer, that's where this 3x squared shows up. It's just the unfolding of the chain rule. So when you take the derivative of sine of x to the third, that is cosine of x to the third, then times the derivative of that inside function, which is 3x squared. So this, if you take the derivative of this, that's just how the chain rule is going to work out. Now, I think it'd be good if everybody got to the point that if you just had the problem and you're trying to figure it out, you'd notice that, oh wait, if I take the derivative of this, it's going to be that part. And you can see that answer. You can see that answer would work. Or you would know that, oh, if I choose that part right there to be u, then this part will be the du, right? If we actually made that choice and we said, all right, we're going to let u be x to the third power, then du would be 3x squared dx. And it's all there. So I want you to, you'll really have to learn to notice that about the problems, all right? Okay, and that's why, I encourage you to check every problem that you do. And as I've done the videos and work problems, I've checked some of them, not every single one of them, but I've checked some of them, and I think it's a good habit for you to get into. Let's see if we can notice, if I gave you 3 problems, which one can be done by u-substitution, all right? So decide which problem can be done by u-substitution and solve it. So here's 3 problems, all right? X to the 5th power times sine x to the 3rd, 7x times root 1 minus x squared, and then root 1 minus x squared. One of these can be done by u-substitution and the others can't, all right? How do you notice when something can be done by u-substitution? Just as a general rule, if I see that some part of it, if I take the derivative of it is the other part, that's a pretty good sign that you can do by u-substitution, all right? So is that true for this one? Like if I let u be x to the 3rd power, then du would be 3x squared. I mean, that's x to the 5th. That's not 3x squared. And it's not even the 3. I mean, if you divided this 3 away, and you get like that, that's still x to the squared, and that's x squared, and that's x to the 5th. They're not the same, okay? Whoops. So this is just not going to fit. If that was an x squared, it would be doable. But as it is, it's not, okay? So all right, this problem here, I'll make the statement. Can't work this one by u-substitution. Okay, there is a way to do it. There is a method, and you'll learn it in calculus 2. It's called integration by parts. All right, but for now, we're going to recognize that u-substitution is just not going to work. You're not going to make everything fit up there the way you need to in this problem. We can't do it by u-substitution. What about this one? Can we do this one by u-substitution? This one I think we can. Because if I let this part be u, I can make that the du. So like here's what I mean. So u is 1 minus x squared. Say that's my choice. Can that 7x dx somehow be incorporated to be the du? Let's see. So let's see. Du, what would that be? That'd be negative 2x dx. So I've got an x dx. So let's do 2 things. One, this constant right there being 7. Let's factor that out. And then let's do some typical kinds of rearranging in there. I'll write 1 minus x squared to the 1/2 power, and then x dx. So yeah, I can make that the du. I can make it happen. I'll just divide this -2 on both sides. Okay, so yes. So what we want to do is look at that and notice that if I let that be u, this other thing, that can be the du. I can get both of them substituted. Remember, that's the objective, is to substitute the x and the dx in terms of u and du somehow. So this one is doable like that, right here, right here. Okay, so we get 7 u to the 1/2 power x dx. That will be du over -2. This as a factor of a -1/2, which I'll also remove. And out here with the 7, that's going to be 7 times -1/2. That's -7/2. U to the 1/2 power du. And then so my answer, I'll get -7/2. I'll carry this constant along. Antiderivative u to the 1/2 power. I know how to do that one. That's u to the 3/2 power over 3/2 plus c. Turns out then that this is -7/2 times 2/3. Okay, so it's going to be -7/3. 7/2 times 2/3. U is 1 minus x squared. 3/2 plus c. All right, so we got that one. Maybe you can see how when we check this, I'll bring that 3/2 to the front. It'll get me a 7 and 2. Then the derivative of that inside is a -2x. Through canceling, I'm going to get that 7x. Okay, but check it and you'll see. But for now, can we see how when we look at it, I can get the u and I can get the du? We got to recognize that. I can't do that here. It just doesn't work. I can do it here. What about this last one then? Can that be done by u substitution? Well, if I was going to do it like this, I think I'd just get stuck. I'd say, well, I'll let that be u, but what would the du be? You know, here I've got this part and there, and then, you know, that part with a little bit of work can be the du. I can get all of it. Here I can't. If I let u be 1 minus x squared, the du is going to be -2x dx. How are you going to make that fit? There's no x dx, okay? We would need x dx somewhere to make that happen. All right, so this one we can do by u substitution. This one we can't. They look similar to each other. All right, but you just can't get the du to show up. All right, so I'll make my statement about it. This problem right here, can't work this by u substitution. Can you do it somehow? Yes, you can definitely do it. There's a method. The method you learn in Calculus 2, it's called the method of trig substitution. It's fairly complicated. But for now, I need you to recognize a problem that cannot be done by u substitution versus one that can. All right? If you decide what u is, if you also see how the du can be incorporated, well, then you've recognized that it can be done by u substitution. If you try and you just can't get it to fit, well, then, you know, there are other ways to do problems. Not every problem can be done by u substitution. But at least for now, I hope that we're getting to the point where we can recognize the ones that can.